This presentation is delivered by the Stanford Center for Professional Development.
Hi, welcome to CS106B, Programming Abstractions. Maybe now our mic is on. Oh, that's interesting. Okay. The website actually was probably the most important thing to take away from here, right, is where can you find information about the class. We're going to talk today and give some overview and stuff like that, but this is kind of the home base for all the materials. So if you manage to get the handouts on the way in, you're golden. Otherwise, you can grab them from the website. There's a lot of just background information, staff information, office hours, all sorts of stuff there gathered. So it's kind of one-stop shopping for figuring out things about our course. Let me tell you what I'm going to do today. The first day, right, I know a lot of you are shopping, trying to check out, figuring out what's the right fit for you. So hopefully today I'm going to try to give you some information that will help you make a good decision. Want to tell you a little bit about what our course is about, tell you a little bit about the administration and logistics. Most of that stuff's pretty ordinary and you can read about it. Then, of course, I have to do a little bit of marketing. I get to give you my unbiased opinions of why this is the absolute best class you could possibly take. I get paid per student, you know. No, that's not true. And maybe we'll even have time to check out a little bit of the C++ language before we're done and said today. And need to go away. All right, so let me tell you about CS106. CS106 is the introductory programming sequence here at Stanford, right? So it's our version of CS1, where you start at the beginning when you are interested in learning more about programming. We have a two-quarter sequence, A and B, that kind of follow together. They're not particularly tightly coupled, which is to say if you took A and you took a little break, you can come back to B, or maybe you actually took a variant of a 106A type course at a similar, at another institution. You're probably in fine place for kind of starting midstream. We also have an alternate form of B, the CS106X, which is kind of an honors version of that second course. So after you've taken that first course and you're feeling really jazzed up, there is an alternative, sort of more intense way to get through the second course that's offered. It's offered this quarter, in fact, so if you're actually thinking about that, that is an option for you as well as sticking with us. What do we do in our 106A? A's official title is Programming Methodology. It is starting at the very beginning, and assuming you have no background in programming, is teaching you how it works, right? What the languages look like, what the syntax is like, what things you need to know about how to solve problems using a computer. So it covers a lot of the fundamentals about logic, control flow, and in general, I think of the big issues for 106A having less to do with any particular syntax or feature that you learn about a language, but about how do you solve problems on a computer? How does somebody gives you a specification of you need to write a program that does X, and you have to figure out how to make that happen, how to break it down, how to step through it, how to develop it, how to test it, how to iterate on it, how to make changes in it later, how to debug it when it's not working well. And those things, I think, transcend any particular language. We happen to use the Java programming language in our 106A course because it's a great tool for introductory programming, but I don't think of that as being really critical. So in fact, if your introductory course was in some other language, some other fairly modern high-level language, you know, let's say you learned in Python, you've learned in C, you've learned in Scheme or something other than Java, you're probably still fine, because what we're really counting on in B is that you know how to program, you know how to think like a computer scientist and kind of solve problems, but not a lot of the details of the syntax are going to be important to us. B picks up from there saying, okay, you've got some fundamentals. Let's start really learning some of the techniques that extend the range of problems you can solve. We look at recursion, which is one of the sort of fundamental problem-solving techniques, right, that involves using something akin to mathematical induction to solve problems in terms of themselves. Looking at a lot of algorithms for sorting and searching and hashing and doing things efficiently, right, knowing how to compare and contrast alternatives in algorithms, having some formalisms by which to discuss those things, and learn some of the just classics that are out there for solving these problems. The dynamic data structures, which involves the use of pointers to construct things like lists, trees, and heaps, graphs that model certain structures that are very effective in solving different kinds of problems. We'll work through those. And then a large part of our time is spent on this concept of data abstraction, which is why abstraction shows up kind of as the main word in our title, is how do we, as we start to solve more and more complex problems, right, the code itself can kind of become overwhelming if we don't have some technique for managing that complexity. And one of the big themes for 106B is how we can use this idea of abstraction, building something and dealing with its low-level details, but then closing up the box and now treating it as a kind of fixed entity and building on top of that, and then perhaps closing another layer around that as a way of kind of working on something and then finishing it and moving on to some larger piece without kind of having those details be clouding our way, as a very powerful technique technique for solving larger problems. And in that context, we'll be looking at some of the classic data structures like stacks, queues, lists, maps, and sets as part of the domain for that. We do happen to use the C++ programming language, but this is not a C++ course. So to be clear about what you're getting versus what you wanted, that we use Java here as a vehicle, we use C++ here as a vehicle. We happen to think there are good reasons to actually expose you to both languages. I'll talk about that a little bit more later. But in particular, C++ is an enormous language. It has a lot of language features as well as a very, very large standard library. And our goal is not at all to turn you into like this industrial strength, knows every detail about quirks and ins and out of C++. There's another class, 193D, that does attempt to do that. And if that's what you're looking for, I suggest you take a look at that. But what we're here about is learning advanced programming techniques, taking those foundations and building on them to be able to solve more interesting problems. We happen to use C++. You will learn some C++, but I almost consider it a side effect of what we're doing. So just to be clear on that. So just a little note on placement. If you're kind of in between and not really sure, these are the very, very rough guidelines, but that they give you some idea of which groups sort of gravitate toward where. Right? If you are new to programming or you're not confident about your background, maybe it was kind of a long time ago, maybe it was self-taught, maybe it was in a course that you felt was not as good as it could have been, or you didn't do as well in it. 106A is a great place to start. Right? It actually is by all accounts an extremely popular course at Stanford, right, and services a wide group of people with a little bit of background or some no background, all very well getting them up to speed. If you do have something like a solid first course experience, so you did well in our 106A or took a similar course or perhaps even self-taught your way through a lot of those materials, right, and you feel ready to move on, 106B. So an AP course in high school, the A curriculum is a pretty good match for the 106A here, so you're in great place. If you have this and you got a little bit more going for you, or you're just super enthused, you have a lot of extra time this quarter, you want to sit in the company of only the uber geeks, you can check out 106X, which is the variant of B that covers the same kind of topical ground, but at sort of a different level of intensity. So kind of amps up a little bit of the assignments, covers some material that we won't get a chance to cover, and just pushes the envelope a little bit there. If you actually have experience comparable to the first two courses, right? So you've done all of the things that we're talking about here in B and you feel comfortable with it, it might be that the right place for you is 107, which is the third course in our sequence, and just skipping over our 106 courses entirely. That's somewhat rare, so if you're thinking about that, I encourage you to talk to me a little bit to make sure that you won't be missing out on something important in doing so, but certainly there are students who have, for example, the APCS-AB curriculum is pretty comparable to this course here, and so depending on how high quality the course you had was, it might very well be that 107 is right. In some situations where that course was maybe a little bit lacking, there may be some ways that we can help just reinforce the things you've learned and just kind of build a stronger foundation to move forward from rather than kind of jumping ahead. So any questions about kind of placement, general sense about that sort of thing? Am I talking too fast? Good, I like that. You can sit in the front whenever you want. All right, so then let's talk philosophy. Because I think, there's this statement about what we officially are, but I also think that the 106 has a very long tradition at Stanford that comes back from actually student motivation, which is interesting. I was here as an undergrad actually in the 80s when the 106s were just getting off the ground. And at the time, Stanford only had a graduate computer science department. And the kind of belief in the kind of nascent period for computer science was, well, that you should get a math degree and only then would you be mature enough to learn about computers. That somehow that there was, you weren't ready as a freshman. And there was just a groundswell of Stanford students who were like, we want access to programming, we want it, that kind of made it happen. And so part of the 106s was a really careful thought, though, about what the 106s would be at Stanford and what we want them to be in a kind of philosophical sense. And one is that we welcome all students of all majors and backgrounds. We don't have a version of 106 that's for the majors or potential majors, and a version that's for the non-majors, and a version that's for, terminal for you just want to get out of here. We really think that we can bring you all together and design a course that actually addresses kind of this wide disparate group, but still service that well. Partly because you don't know that you're a CS major yet. I'm going to turn you into one. That's my plan. That at Stanford, right, not having to make that choice about a major until into the junior year. is a gift, right? To allow you to explore and to feel unencumbered by having made some decision when you applied. And I think it's important to kind of respect that gift that Stanford gave you by trying to make sure our courses don't funnel you one way or the other before you figured it out. So you are all welcome here. We try to make it accessible to everyone, and we have certain plans that I think help to make that work, right? We do try to provide a solid practical foundation in programming that, given our placement at Stanford in the middle of Silicon Valley, there's kind of a strong influence for us to try to produce students who actually kind of from the get-go are learning things that are actually quite useful outside of the classroom, rather than kind of teach you a very academic and perhaps very interesting and mathematical language like scheme, but that is very rarely used outside of the classroom, trying to teach you on the tools and languages and techniques that are actually in active practice. So we are using Java and C++, two of the most prevalent languages out in the industry. And we do a lot of learn by doing, right? We assign challenging full-fledged programs, right, that you work on and you build. And so it is not designed to be academic exercises, that you really are building skills that have applicability here and outside of the class. We have a big emphasis on truth and beauty. That this is one area in which some of the substitute courses that we have seen students come in with have a little bit more trouble with is tackling this part of it, which is that there are a lot of ways you can get a program to work. And many of them are not pretty. You can just type and type and type monkeys, Shakespeare or whatnot, and eventually you can kind of get your way to something that kind of works. Keep changing stuff. Well, +1, -1. Oh, what if I move it here? What if I copy and paste this there? What if I change that name? That in the end might produce a program that from external appearances works. It plays hangman or whatever was the desired goal, but that internally is a mess. It's not well structured, it's not well commented, it's not easy to understand, it wouldn't be easy to modify. It makes a lot of decisions that are really suboptimal. And we're really interested in producing engineers that have a good sense of design and that really appreciate what is involved in writing good software, well-designed software, not just working software. So we will be giving you feedback on both kind of the correctness, functionality of your code, but in as important, if not more so, also on how well we think you did at designing and implementing and writing code that is of a high quality. So we make a big deal out of that. That is something that is not always shared by other classes, and so in particular, someone who is self-taught or in a class that didn't emphasize this might feel that there's a little bit of a gap there where we need to kind of make that up with you, and we can work with you, because in fact this is a very individual thing, because there's not one good example of the perfect style that in the way that a lot of different people express themselves in written communication very well, but differently. The same thing is true about programs, right? You will have your own unique style, and we'll work with you to kind of coach you on getting your style to come through and be beautiful and elegant. This kind of comes back to almost point one as well, is that we make heavy use of undergraduate section leaders as mentors in this program. So we have a staff of 50 or so undergraduates who work with the 106 A, B, and X courses as a team, and they have specific responsibilities with their section. So mentoring and grading and meeting with the sectionees to give individualized feedback on their programs and stuff, as well as just answering questions, solving problems, being in the lair 30+ hours. So we're there most weekday nights, about 6 hours, and often well past the midnight when it's supposed to cut off, just solving people's problems, helping you when you get a little stuck, answering your questions, and making sure that you're kind of all making forward progress. And that comes back to point one, that in some universities, I think, where they're choosing to use their intro course as kind of a weeder. It's like, well, let's separate the wheat from the chaff early, and let's make it really hard and not provide too much support, and that way we'll make sure we get the people we want. And we really have a different idea that programming is hard, especially when you're learning. There's a lot of complexity to master, and there are a lot of details that can interfere with kind of moving forward, and we don't want you to get stuck on something that we can very easily resolve for you. So trying to make sure you have accessible staff members in person, in email, regularly in section, to help get through your roadblocks and keep you moving forward. What do you need to know to be sure you're going to do well? There are people who think that, to be a good computer programmer, you need to be good at math. You need to be good at logic. You need to be good at drinking Jolt. I think actually it comes down to more personality traits than I think any particular technique or skill. Like, you don't need to be good at math, right? How much, calculus and trig shows up in this? Just not very much, right? A little bit of logic, that helps, I think it comes down to more things like traits like curiosity and determination, hard work, that starting early asking questions when you don't understand something. Trying to solve the problem by logic, I think, is very valuable, knowing kind of how to think about how to make steps, why this case works and why that case doesn't work, right? Thinking about that logically. Well, it's like the movie theater. Now you guys will all go to sleep. Oh, look, they came back. But that, I think these are the skills that actually kind of serve you the best. And they serve you the best in this class and probably every other thing you'd want to tackle. But there is a lot of time that will be spent here to master this. I can talk about programming all I want, blah, 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 blah. And you can go, oh, yeah, that makes a lot of sense. But when you go to write it yourself, right, it's a very different experience. And that's where, being kind of focused and staying on task and getting help when you get stuck can help you move through that. All right. Any questions about 106? What we do, why we do what we do? You guys have nothing to say. You're afraid of having your voice recorded, aren't you? For all time. Then your parents will come and see that you come to class. You can prove it. All right. My unbiased opinion about why 106B is one of the best courses at Stanford. Of course, I'm not at all unbiased. Okay, it's going to be totally obvious when I say these things, and you guys are just going to have to go along with it. I'm actually a geek, really big time, right? And I happen to love programming, and that's why I'm a perfect fit for teaching this class. I have taught 106B or X more than I've taught any other class that I've taught at Stanford in my time here. And that's because each quarter when we're setting up the schedule, I say, give me B, give me X, because there's no better course to teach. Programming is just awesome. If you love programming, I think there's almost nothing better to do in the world. You have this task, you're trying to get there, you're coding, you're making stuff happen, you're testing, you're iterating, you're running, it comes back around, you see stuff, you build things, right? You can, when you're done, you know it works, right? That feeling when you're writing a paper and you're like, well, is it good enough? Well, I don't know. You could probably go bolster up this argument. Like when a program works, like you can know it. You're like, yeah, that does what it's supposed to do. It gets the right answer, it plays the game, it solves the problem. Finding and fixing that last bug, although debugging is kind of one of the aspects of programming a lot of people bemoan about, I happen to think that if you're driven by debugging, like that is one of the most awesome little detective stories ever, right? It's like trying to figure out why it happened when you did this, when you moved that, why it went this way, and what this effect caused, and then understanding once you make the fix, how it fixes it. Staying up late, I have stayed up late more nights debugging than anything else in my life, and I'm not sad about that at all. So that means I'm in the right place. Hopefully some of that resonates with you. Just a little bit. If that totally sounds really awful to you, hopefully we can change your mind a little bit. But that is in some ways part of what drives computer scientists, I think, is this kind of wanting to build things. We are engineers, right? We're part of the School of Engineering, right? We have this computer science name. Just remember, any subject whose name is something science is not a science. But, we're trying to puff ourselves up a little bit. But we do a lot of really great work, right? And there are a lot of neat scientific principles and theory that underpin what we do. But in the end, I think what drives a lot of us is just the engineering, building stuff that is really neat. It kind of reminds me that my husband's a mechanical engineer. And so I used to be kind of envious because he would always build things. You see the MEs, they're always toting foam core, around the campus, and their paper bicycles and stuff. And it's like, they build all these things. But now, having watched all the things he built, it's like being an ME is really hard, actually. You need all these materials, you need all these tools, you need this mill, you need this lathe, you need the hot melt glue gun, which burns the heck out of your fingers anytime you touch it. And to build anything, in computer scientists, you don't need anything. You need a compiler, you need a computer, you need your thought. It's like it's this abstraction we built out of our brains, right? And there's this relatively small set of things that you need to kind of master, and then you can combine them in these very sophisticated and interesting ways to solve all sorts of problems. But there's a very low overhead, and the range of things you can attack with the same set of skills is huge. Like every domain out there can benefit from somebody applying computers in a useful way without fail. There's all sorts of problems where technology is part of the answer, not the only answer, but certainly something that you take whatever interest you have and combine it with computer science and construct something cool. I happen to think that what happens in the second course is amazing. That the first course, you kind of got to get up to speed, and there's a lot of basic material that needs to get covered, and it does kind of set you on the right path. But in this course, actually, we really get to blossom beyond the basic things. That there's a bunch of really neat and very accessible techniques, right, that a second quarter student can understand and master and do really cool things with. So you can learn how to do something like create a database that has 1 million entries, right, and then ask for somebody by name and be able to instantaneously find that name. Not by looking through 1 million entries one by one, change the size of it, make it 10 million, make it 1 billion, and still be able to provide that kind of instantaneous access. You're going to learn how to do that, right? And the technique is not, some superhuman thing. It's something very clever, admittedly, but but it's very accessible. Taking that same million thing and learning how to sort it efficiently. What if you happen to know things about how it's almost sorted, but just a little bit out of sorted? Are there ways you can actually make it even faster to put it in sorted order? There are techniques, for example, like recursion, that take on problems that you might not have any idea when you first look at the problem how to solve, but once you've kind of got your head around recursion, you can look at that and say, I can write a 5-line function that will solve that problem. And this is the kind of power we're going to give you with our quarter together. So there's a bunch of really amazing theoretical and algorithmic stuff to explore that really increases the kind of things you can do with programming. So I'm particularly fond of it. And as always, I think the section leading program, right, that we have created and built at Stanford is a huge part of what makes our 106 courses so successful. And so having somebody who's individually kind of working with you, meeting with you weekly, and giving you that feedback that's individual and personalized for you and helping you get through the rough spots is a lot of what helps to make the experience very fun and kind of very personal too. So, and maybe I'll say for a second, like, what section leaders do I have here? Any? Not a one. Those fabulous section leaders, where are they again? Did I say they were fabulous? I meant, no. We haven't yet identified who's going to what class, so maybe they're all thinking they're going to go somewhere else, but they're wrong. We'll get some. All right, so 106B, great. You agree? Have I convinced you? Are you sure? Is anybody still hesitant? Something else you're worried about that I can tell you isn't a big deal? Is it a lot of work? Oh, no. I just exude it. It just osmosis. You'll learn it. Okay. Well, let me tell you a little about logistics, because there are some just random things, right, that you may want to know about how a class works that the first day I'm supposed to do. Okay. We're going to meet here Monday, Wednesday, Friday, 2:15, 3:05. In glorious downtown Skilling Auditorium. It looks like we almost exactly fit in our classroom, which means we're all going to be very friendly and cozy. The lectures are being taped and available online, and so that has the neat side effect that you can watch them, you can review them later. You could watch them lots of times, right? It also means that if it were pouring rain and you were sitting at home in your bunny slippers, you could just say, hey, I'm not going outside, and you could turn on your computer and watch. I'm a big fan of having you come in person. That's because I don't want to lecture in an empty room. But I also think there's an interaction there, right? Like sort of the human-to-human thing that I'm kind of fond of, and so I hope that you will make every effort to attend in person as much as you can. But it is nice to know that if you do miss a lecture or you get caught up with something, you'll have a chance to review it later online. We will have sections that will meet once a week, just like 106A. The section leader, right, who meets with you in the discussion section is the one who'll be grading your programs and sitting with you and doing the conferences with them. What you need to do to get yourself into a section, there's a bunch of section times listed in Access, and they're just totally bogus. So ignore all that. What you do is you go to the online, if you go to our class webpage, there's a link that tells you how to sign up for a section. The section signups aren't up right now, but they will go up tomorrow, and they'll be up through the weekend. And you go in and you put in your preferences about what times fit in your schedule or not. And there's this big, you guessed it, computer program, right, that does this magic matching that gets everybody into a section that fits into their schedule that will happen by early next week.
If our schedule changes, what's like the last point at which we can change sections?
So the signups will be up from Thursday at 5 till Sunday at 5, technically. So if by Sunday at 5 you know what your section, you've got your schedule fixed, then you're fine. If you happen to change after Sunday at 5 and after the assignments have been made, at that point it's a little bit harder. We can make adjustments, but it's on a very case-by-case basis as to where we have space and where we can accommodate you. So the best thing you can do is by Sunday at 5 have a pretty firm idea about what you can and can't do. I mean, there's a list of preferences, so maybe what you can do is pick things that you know will work no matter what happens. For anything that's variable, maybe just don't offer things that you know might go away. So there's a list of 20 times, and you say I can make these 5, and that way you won't get yourself into trouble on the ones that might change. The workload. Everybody always wants to know, well, how much work? It's a 5-unit class, and it's a 5-unit engineering class. So you get your 5 units worth, I would say. So don't worry about that. I won't shortchange you. We have programming assignments assigned. They're not quite weekly. I think there's 7 of them across 10 weeks. So you can kind of calculate it out. It's about a week and a third for any particular one. The student report that it's about a 15 or 20 hour project, each of them. Some people get them done in less than that. Some people take a little bit more. But I would say that's kind of the mode range for what people are reporting. I do think that of the people who report less, some of those are actually, some people are just very naturally gifted and whatnot, but a lot of them has to do with your habits about how you work and how you make progress. And so if you are one of the people who feels you might be more likely to be on the other end, you can definitely come and talk to me and I can give you some suggestions. In particular, things like choosing to work in the lair where the helpers are on duty actually has really positive effects in that when you get stuck, right, you have easy access to somebody helping you work through it rather than spending an hour or two kind of fighting something that turns out to be kind of simple but just required knowing something that you didn't yet know. Although I'm a big fan of learning things yourself, there's also times when actually a well-placed bit of advice from somebody can save you a lot of time. So as a strategy. There'll be a midterm and a final exam. They'll both be kind of an in-class, so not take-home, open book, open notes. The midterm is actually technically out of class. We're going to have it at night because we need more than a 50-minute period to get any coverage of that. And then our final exam is scheduled in our university scheduled slot. Sadly, that is at the very, very, very end of the exam week. But that's when the registrar puts us, and that's where we need to go. So you may want to take a look at that before you head off to Acapulco for spring break to make sure you're going to be here for the exam.
Is the course available anywhere? Like, is it available?
Unfortunately, our publisher will not allow me to distribute the course leader electronically. They're not exactly very in the modern age on this. So,
Doesn't that kind of hurt the whole
yeah, I'm working on it, is the truth. So that, by the time the world sees this, hopefully we'll have some other strategy, but we currently are in negotiation, let's say, but they are not. The nice thing about the course reader is we have not changed it in the last year, so if you know somebody who has it from last fall or last spring or something like that, it has some minor edits and typos that were fixed, but so if you can get a hold of an old one, it's good. We are getting no royalties on it. We're publishing it at production cost. So it's actually, like where it would have been a $100 textbook had it been bound and all snappy. You're just getting what it costs to photocopy and bind the thing, and Eric and I are just, eating ramen. And so it's hopefully cheap enough, right, that you can find a way to get to one or get an old one without it being too much of an obstacle. So that's it. People, I think, in general find the course reader to be an asset. We do say it's required reading. It does have a lot of material that's very useful in kind of understanding the course. There are other people who don't make as big a use of that, but there are some sections I think that are just really very, very valuable, and other ones that may be more or less depending on kind of your learning style, whether you appreciate more of a chance to read background material and see more examples. And there's also a lot of good sample problems in it and review questions that help to kind of test your understanding. It's tricky, right? Because the university in general, it discourages you from giving alternate exams because of you can imagine the issues of having an exam that actually has been seen by some number of students before some other number of students take it. Even though we're all bound by the honor code, it does kind of create a situation where there is some temptation. And so it's possible it could be a little bit early, without a lot of gap, but I don't think early enough to make a lot of help is the truth, right? We can talk about it though, but the current plan is not, I would say. So if there's something really important about that, that you definitely know you're not going to be around at the end of the exam week, that's going to be a problem for us. You need to talk to me. And then a little bit about compilers that we use C++, and we also use some custom libraries, which limits us to distributing on a certain number of platforms we've had a good chance to test on and work with. So the compilers that we have support for, right, is Xcode on the Macintosh. Xcode is Apple's free developer tool, so anybody who has Mac OS X can freely download that and install our libraries. We're using Microsoft's Visual Studio version 2005 on Windows, and we have an arrangement with Microsoft where they have distributed the software free of charge to students. So if you would like to install that on your own Windows computer, we're going to give you some handouts on Friday that tell you what you need to do to kind of go get the compilers and get it installed onto your system. So thank you to Microsoft for that. And then our cluster computers in the dorms and the libraries and the lair have both of the Macs and the PCs have the compilers and libraries installed, so that if you actually just work in a cluster, you don't have to do anything special at all. You just walk up and it's got the stuff ready to go. Well, hi, you can't ask me that because, of course, I'm totally biased. I'm a Mac person. I've been a Mac person forever. So I can't get over the fact that you go to the Start menu to shut the machine down, and that makes Windows impossible for me to use. I would say though, campus-wide, right? There's a mix of people. Probably there are more Windows machines than Macs on campus. So if you want to take a popular vote, you could do that. But if you want to be on the side of the Mac bigot, you can come be with me at Xcode. I happen to Xcode's a very nice compiler, but Visual Studio also seems perfectly serviceable. So, okay. All right. Well, look at this. I've got 10 minutes, maybe a little bit more, to tell you a little bit about C++. Because that is the next journey, right, that we're going to go on together. C++. So it's like the first question I'd say is, why are we doing this to you? You're like, I just got comfortable with Java, and now you tell me to throw away my Java and start over. Okay, so let's generate a little bit of love for the C++. Okay, I put this: the advantages of early multilingualism. So I have 2 small children at home that are 2 and 4. And I read a lot about bilingualism and stuff, sort of raising your children in kind of a global world. And there's, very, very clear evidence for natural languages, right, that when you're acquiring a language, at those young ages, right, that is the best time to introduce a second or third language, where you're kind of building all the pathways in the neurons and stuff. There's some really very neat research there. And so the same thing has been looked at in terms of programming languages as well, that when you are learning a programming language, right, there are certain kind of ruts your mind gets into about the way a language is that is based on your experiences early on. And if you spend a very long time working only in one language, those ruts get deeper. And you have a certain way of thinking, right? You're kind of a little bit stuck in that paradigm and its approach. What's easy to do in that language, what's hard to do in that language, right? Tends to kind of make a stronger impression on you in a way that makes it harder as you grow and explore other languages to kind of get out of those ruts and kind of shake yourself out of it. And so there's been some pretty good evidence that that about 1/4, somewhere between 1 and 2, is a really good time actually to think about branching out a little bit and starting to think about different ways of doing stuff and seeing some different syntax and some different ideas to help kind of just build in the flexibility from an early age in your career to kind of buy you some strength later. So that's part of what we're doing. Some other part of it is actually that a lot of our upper division courses, right, rely on a knowledge of C and C++, that family of languages, and that the longer we postpone it, the kind of more painful it becomes. Because in the later courses, right, when you're learning about compilers or graphics or networking, they don't really have the time in those classes to stop and teach you C or C++, but they need you to know C++ to get the work done. And so it's like, where are we going to make sure you get this foundation? And sort of moving it into a programming class seems to make the most sense in the context of our curriculum. So we do switch you over here. The good news is, right, is that it's not as big a change as it might sound at first glance. To say I'm going from a totally different language. Well, Java actually is highly derivative of C++ for a start, right? They're kind of cousins in the scheme of language design. And in fact, right, they have a lot of syntax. So I say, well, how much C++ do you need to know to start? Okay, here's the answer: 0, right? You don't even need to know what the word means, right? You can say C++, well, okay, whatever. In fact, you actually probably know a surprising amount about C++ just by virtue of what you already know, just translated a little bit. That things like, let's say, the for loop of Java, or the way you declare variables, or the way the parameters are passed into a function, is exhibited in Java in very much the same way it is in C++. So there's a bunch of things you actually already know and you don't even realize it. But it is not assumed, right, that you know C or you know C++. If you happen to already know those things because you had your course or some of your background was in that, you're ahead of the game. If you have not, then not to worry. So what we're going to do is say, well, how much C++ are you going to learn, right? So we will spend the first, I think, 3 or 4 lectures just talking about how things get expressed differently in C++, and mostly actually talking about the differences in the libraries. That the syntax itself is quite similar, that some of the more extensive changes have to do with, well, how the C++ string is operated on versus the Java string. How you do file input-output reading in C++ is a little bit different than the way it's done in Java. So we'll spend some time saying, okay, well, here's some things you know how to express in one language. We're going to teach you how to express them in another language. So it's just mapping from your previous vocabulary onto a new one. Then along the way, we will actually introduce some of the C++ features that we need to support our pedagogical goals. So we'll be talking about how classes get designed in C++. We'll see how to use classes. We'll see how to actually define those classes. And we will be looking at things like templates, which is the C++ construct for doing generics that you've seen in Java. So how you can build containers that are type unspecific and things like that. We will learn a little bit of some of the fancier features of C++, like let's say the pass by reference parameter, but there's actually a very large amount of C++ that's just off the table for us. So we will not make extensive use of for example, the standard template library or the fancier features of static and const and a bunch of keywords, that mean nothing to you and should mean nothing to you. So you will learn, enough to I think have reading familiarity with C++ and to be able to express yourself quite well in the subset we're using. But it is a subset of C++, right, that you're being exposed to, and that there is. Oh, that's something I should have told you about in logistics, but maybe I'll mention it right here, right? Which is that if you find yourself really wanting to kind of master C++, right? You've got these programming techniques, but you're kind of curious about the other areas of language that kind of outside of our purview. We are offering CS106L. CS106L is a lab companion course that is open to students enrolled in 106B or 106X. It meets twice a week. It's actually on Monday, Wednesday, late afternoon. I think it's 4:15 in Hewlett 103. And it's being taught by a veteran section leader who is very well versed in C++ and who, in fact, kind of his own volition, kind of volunteered and created this course out of nothingness because he himself was a little bit frustrated as a prior 106 student and how wanting to get at some of those C++ things that really weren't fitting with our goals. So it is a place where you can get sort of just more exposure to standard C++, do a little bit of exercises that help you to test out those things and see how those things are expressed and get another unit. It's a pass-fail lab course. You can also just attend or just grab the materials if you just want to just look at them, if it's not something you want to take the full commitment for. But a great way to just kind of broaden that knowledge of C++ beyond what's useful for us in terms of our goals. All right. Now I'm going to ask you some questions because I don't get to do all the talking. All right, so how much C++ do you need to know? Some of you may know nothing about it, and that is perfectly fine. But some of you probably know something about it, or at least have heard something about it. So I'm going to have you guys tell me what it is that, from an outside perspective, what it is that people tell you about C++ that seems to be, makes you either excited to learn it, or frightened to learn it, or interested in how it works? What do you know about C++?
What Java is based off of.
It is what Java is based off of. So that should be hopefully a little reassuring, right? That there's a syntax there that kind of got adopted with some minor changes. So in fact, right, that it should feel more familiar than different, at least when you look at it. So that's a very good thing to know, right? That it was very strongly influenced by a generation of programmers who C++ was their native language, right? Who designed the Java language. So that's a good thing to know. What else do you know about C++? Help me out.
It's extended C with the object-oriented program.
Yeah, so it's extended C. So here's how it kind of fits in the spectrum. It's like, well, C is kind of a 1970s creation, right? C++ is about a decade later. That C is the language in which it's based on. And in fact, it is an extended C. It's called a superset, that everything that compiles and works in C still exists in C++, but then they added a bunch of features. And not only did they add a bunch of features, they tried to fix some of the things about C++ by replacing existing things. For example, there's some string handling in C, but that's kind of very primitive. And so they added a string object with much cleaner handling and safer semantics into the C++, but they kind of left the old one around. So some parts of C++ that feel a little bit strange because of this history to it. The legacy of incorporating everything C was, plus this stuff, means at times there's a little bit of some weirdness there. But it also means that the language, as a result, is very large, has kind of a whole other language inside of it, plus this object-oriented, and a bunch of features way beyond object-oriented, in fact, right? Just tried to solve a whole bunch of other problems about, for example, C's type safety and runtime features, right, were kind of extended by what got added in C++. What else do you guys know? The other, 198 of you have never even heard of C++. Is that what I'm seeing?
Friend of mine told me that C could do things like type out your computer.
Yeah, that's a good thing to know. So you're hearing C++ might be a little more dangerous than Java, right? And that is true, right? It's not a wipe out your computer may be kind of a slight exaggeration of the situation there, but that Java as a family is very concerned with safety, and in particular since Java was designed for kind of this web delivery of content, right? It was very important that the program actually have very constrained features on what it can and can't do. And so as a result, Java, right, tends to be very parental. You might have remembered from working in 106A, it's like when you forget to initialize a variable, when you forget to return from a function, when you call a function with the wrong number of arguments, all these sort of things, Java's very aggressive about saying, hey, you got to fix this, I'm not letting this go. C++, a little less parental, right? So maybe here's the kind of overly protective mom, helicopter mom, they call them at the park, the ones who kind of stand. That's Java. Java's making sure that, oh, are you okay, sweetie? Let me stand right here in case you fall. C++ is crack mom. She's like, yeah, I'm over here with my friends. Yeah, don't play with the kitchen knives, right? But then turns her back, right? And then of course, what do the kids do? They're in the kitchen knives. So it has, it's a professional's tool, right? And professionals don't want to feel encumbered. There's certain things they want to do that require kind of some of this low-level access, and safety usually comes at a cost, right? Any sort of feature where the language is double checking for you is taking time. It's taking efficiency, right? And there's a cost associated with that. If every time you went to go get something out of an array, it checked to make sure that that number was not off either end, then every array access costs you a little bit more. C++ says, I'm not going to charge everybody that penalty. If you actually have the bad sense to write a program that does those things, you deserve to be punished. And as a result, right, you will certainly at this time, at some point this quarter, kind of get to experience a little bit of that firsthand. Some of it is a growth experience, right? Let's say some of it can be frustrating, but it is sort of part of what professional tools often look like, right? Is they are making these trade-offs over efficiency, over safety that put more of the work back on you as the programmer to be a little more attentive on those things. So it does mean you can write programs, right, that crash in very spectacular ways, much more interesting and varied and dangerous than the kind of things you can do in Java. Good to know. Anybody have anything like exciting about C++, something they want to be able to do that they think C++ might be the answer to? You want to use pointers. You're going to get to use pointers. Pointers are really, really neat. And they're also very, very challenging. Pointers are these ways of building these very flexible and amazing data structures, the kind of things that we're going to try to build, right? At some point, they are going to be the only way to achieve those things well. So building these things called trees and graphs and lists, right, rely on having understanding and mastery of the pointer type. But the pointer type is complicated, and it's part of that danger thing, which is having access to kind of rearranging memory by virtue of addresses, right, just opens up a lot of opportunity for there to be kind of mistakes. Mistakes can be made in the passive voice that have consequences, and you will get to experience firsthand what that's like. There's joy in it because getting it right is awesome, and there are things that you can achieve that are really extraordinary with pointers, but when it's not working, it can be frustrating. So you're getting kind of a little bit of both. Anything else you want to know? You want to tell me? Yeah.
How do graphics compare to Java?
So it turns out C++ does not have a graphics system built into it. So Java is actually quite distinguished from the previous languages in the sense that Java really tries to solve all problems. That traditionally a programming language tends to have a set of libraries that have facilities for data management and files, reading and writing files, sometimes some networking, but they don't tend to actually solve application layer problems. That tended to be a different piece of technology. Some vendor, like the Mac OS, might offer a graphics library that was written in C++, but C++, the language, right, didn't have a windowing system or graphics system. So C++ does not have those features itself. So any C++ compiler you get, comes with these basic things about handling files and managing these type of data structures, but it does not come a priori with a bunch of graphics routines. That said, Windows and Mac and Linux and all these things have graphics routines, right, that are written in C++, but they're all different. And so to say what are they like relative to Java, they're all different relative to Java. So at least it's not standardized. And so but there's a wide variety of them out there, and they tend to have a lot of very impressive and different solved problems, right? Because C++ actually has a longer history than Java, right? That a lot of problems have been solved in C++ that are available to you too. So there's kind of a lot of existing code that, other than what you might think of as standard. All right, I was going to show you a C++ program, but you know what? What I'm going to do is I'm going to give you 2 minutes of free time, and that way we'll have goodwill. So I will see you on Friday, and we'll be showing some C++. And if you have questions about your situation, come and talk to me now. It's a good time.